Okay, now we're going to construct the graph of the toolkit reciprocal function. I'm going to start with a square. Pretty close to square anyway. Now I can kind of draw a diagonal line from the upper corner to the lower corner, go through, draw a line from here to here, on this here. I'm going to put my red dot at the center, then I'll get rid of those little segments. Okay, so the square you start with is still 4x4 square, but the red dot goes at the center. Well, excuse me. We're going to do some subdivisions. Subdivisions we're going to do vertically. Just going to do them quickly now without a whole lot of explanation, because by now you should have practiced the toolkit scoring function and the toolkit exponential function until you're confident you can do them with reasonable accuracy and correctly. Okay, so the subdivision on the vertical is going to be identical that we use for the toolkit scoring function. By the right hand, the rectangle on the right hand side in half, and then that new rectangle in half. Always going toward the center point. And then at the left, we do the same thing. Okay. Then, first of all, we're going to do something very similar to what we did with the toolkit exponential function and the toolkit scoring function. We're going to subdivide the whole rectangle in half horizontally. And we're going to divide that in half horizontally. Yeah, this half is too big for this half. And now it's going to get a little different. Okay. Now I'm going to divide this rectangle in half. And I'm not going to bother dividing the lower rectangle in half. Okay. Now I want these divisions to be symmetric. So I divide this upper rectangle in half. Then I divide the half closest to the center line, closer to the center line in half. Now I could add a line down here and a line up here if I wanted to make it uniform throughout, but we don't need it, and there are reasons why we don't even want to do that right now. Okay. Okay, well, we're going to start at this point. Then we're going to move one to the right and one down to this point. And then we're going to do this point. Now we can see how this point and this point are in a sense symmetric. If I emphasize this vertical and this horizontal line a little bit, you can see that on the left we start at the first horizontal line below this horizontal line, and then we move to this point. And then this point is symmetric, meaning if I was to take this square and rotate it this way, this point would rotate up and become this point. Now this point would rotate up and become this point, and that would be useless. But this point at least would come up and go through this point. Okay, so there's a symmetry, and you want to be aware of this symmetry. Then what we do up here is exactly the same thing. Okay, take the point that's symmetric with this, and now by symmetric, I'm going to say symmetric through the origin. If I was to I don't want too much of this. As to draw a straight line from this point through the origin, if everything is marked off accurately, I would end up at this point over here. And then I'll move one point to the left and one point up. And then I'll move to this point. Okay, those are my points. Notice that these points occur in pairs. I draw a line through the center from this point to this point. Or if I draw a line from this point to the center, it goes through this point. Alternatively, the center is halfway between this point and this point. And the same thing here. So we have all this symmetry. Now, those yellow dotted lines, you can tell the yellow from the white, the ones I just drew through the center, aren't an essential part of the picture. If we're just trying to draw the graph does this. And the graph does this. Now, what the graph doesn't do is it doesn't connect this point to this point. Okay. This point doesn't connect to this point. Nothing to the left of center connects to anything to the right of center. Now I'll write a few things down and give you a little bit of a summary and a little more information. Okay, so vertical division, just like the squaring function. Horizontal division is a little different. I'm going to say it a little differently than I did before, just to give you two ways to see it or think about it. And you can choose either way, or you can see how both ways work, which is even better. Okay, we divide the square in half. Okay, that's horizontal line through the center, which is the red dot. Divide each new rectangle in half. So, okay, so when you divide it, then you got a new rectangle down here, a new rectangle up here. We're doing this horizontally, so we divide each one in half with a horizontal line. It'd be this line and this line. Then divide each new rectangle adjacent to the center line in half. Now, so you've got 4 new rectangles. When you've divided this lower half in half, divided this in half, we want the rectangles adjacent to the center line. Adjacent means next to. It's an important word, should be in your vocabulary. So this rectangle is adjacent to the center line, horizontal center line. This rectangle up here isn't adjacent. We're not going to do anything to it. Okay, down here, you got this rectangle. Is it adjacent or not? Think it. Okay, well, it's not adjacent to the center line, but this one here is, and we divide it in half. Okay, there we have it. Now, points. But I'll say it like this. There's a point on each of the 4 edges. On the left edge, it's the point, the point is going to be on the horizontal line just below the center line. The point is on the dotted line below the center line. Okay. Right edge, the dotted line is above the center line. Okay. In other words, use the dotted line above the center line at the right edge, and you have this point. And the lower edge, it's to the left of the center line. What's this mean? On the lower edge, you take the dotted line to the left of the center line. There's your point. Upper edge to the right of the center line. Upper edge, take the dotted line to the right of the center line. It gives you this point, this point, this point, and this point. And then, I didn't write it down, but there's only one other horizontal line below the axis, one other horizontal line above the axis. So you just move from this point over 1 and down. You've got to go down to get from here to here. You just move over 1 and down. From this point, you move over 1 and up 1. Okay. Now we could have done it by saying, okay, then from this point, you move over 1 and down to the left edge or the lower edge. Okay, a lot of different ways to say it. Figure out how you want to say it. Figure out what explanation works best for you, but above all, learn to sketch this. Okay. Then, having checked it, check the symmetry. What did I do to check the symmetry? Is a line through from this point through the center going to end up here? Yeah. Is a line from this point through the center going to end up here? Oh, yeah. Is a line from this point through the center going to end up here? Yeah. So we have that symmetry. I'll say, I said through the origin, where the toolkit functions, the origin is going to be the red dot, but I'm not even going to talk about coordinate plane just yet, although very soon we will. Okay. And then don't connect the points on the left and the points on the right. If you connect this point to this point, it gets all screwed up. I'll give you a brief explanation of why it gets all screwed up. The pattern. If you move twice as close to the vertical center line, you move twice as high. This point is twice as high. Okay, but if we measure height from the horizontal line through the red dot, okay, this point is this much higher than the red dot. This point is this much higher than the red dot. And if I divided this so that this is half of this, then this point is twice as high as this one. Okay. Well, here, if I move twice as close to this vertical line, go twice as high. Now, if we keep that pattern up, I can keep going twice as close and twice as high, and twice as close and twice as high. Get very high very quickly, and we get closer and closer, but we never reach this line. On this side, if you move twice as close to the vertical line through the red dot, you move twice as low. And then we move twice as close, we move twice as low. And then we move twice as close, we move twice as low. Go twice as close as that, we're getting pretty close. It's lower than the bottom of the board. Okay, so that's the way the reciprocal function behaves. And we're going to see more about that. Now, you don't necessarily need to remember what I just said, but I wanted to emphasize there's a very good reason why we don't connect this point to this point. It's because the process never gets us from the left side to the right side. If we keep going twice as close, twice as close, twice as close to this line, we never get to it. If we keep going twice as close from this side, we never get to it. So we never get to this center line. So there's no point on the center line. And if you tried to connect this point to this point, you'd have to go through the center line, and then there'd be a point on the center line, and there can't be. Now, you might not digest all that. It's not terribly important right now. We'll talk more about it later when we do the algebra with it. But I want you to be convinced that we don't connect points on the left with points on the right. If you remember that much right now, I'm happy. If you remember everything I just said, well, I'm very happy, but it isn't necessary, so I won't go to too much trouble unless you're really curious. It's great if you are. Okay, there we have it. That's your graph of the basic toolkit reciprocal function.